Hi, this is the multiple choice part of the Unit 8 test for calculus. I'm going to go ahead and talk about the answers here. And we're going to start right with number 1. Okay, we've got to use a left-hand endpoint rule with 4 subintervals to approximate the area under that curve. Okay, well we know what that graph looks like. So I'm going to go ahead and draw the graph like that. Negative 2x plus 9 is a line that looks like this. Slope is negative 2. Y-intercept right here is positive 9. Okay, and we're looking to go between x equals 2 and x equals 4. Like that, like that. Okay, we need 4 subintervals, so we've got to cut this up into 4 pieces. Be nice if I could draw a straight line, but you get the idea. This one's going to be 3. This is going to be 2.5. Let's see if I can fit it in there. 2.5. And this one is 3.5. So what we have to do is figure out the area of each of these rectangles, and we're using a left-hand rule. So we're going to be looking at these rectangles right here, since we're looking at the left side of each of these endpoints. Okay? So, f of 2, plug in 2 here, we get 5. So this point right here is 2, 5. The next one down, 2.5. If we plug in 2.5, let's see, 2.5 times 2 is 5. Negative 5 plus 9 is 4. So this point right here is 2.54. This point right here then is going to be 3, 3. This one is going to be 3.52. And this one right here we really don't need, because we don't need to know how high that is, because we're using the left-hand endpoint of this subinterval. Okay? Great. So now each of the delta x's, each of the endpoints, or each of the interval widths is equal to 1/2. Let me make it a fraction. It'll be easier to work with. If each of the interval widths is 1/2, then the area of each of these rectangles is just the height of the rectangle times the width. So what we're looking at is 5 times 1/2 plus 4 times 1/2 plus 3 times 1/2 plus 2 times 1/2. And I can factor 1/2 out of here and make it a lot easier on myself. 5 plus 4 is 9, plus 3 is 12, plus 2 is 14. And so 1/2 times 14 is equal to 7, and the answer is B. Okay, for number 2. Number 2 is going to be basically the same problem, but they've given us the points on the graph. So we're looking at the velocity of a skier for 24 seconds. We're going to use right-hand endpoint values to estimate the distance using 6 intervals of length 4. Notice how each of these are 4 units apart. That's 4 units in time, right? And you notice how at each of the intervals, the endpoints, we're given how fast the skier's going. If we're using right-hand endpoints, then for this subinterval, we're going to look at this information right here. For this subinterval, oh, no, I blew that. Let me do that one more time. From 0 to, okay, that's right. I'm confused. There's a subinterval, okay, and 1, 2, 3, 4, 5, 6. Yep. Here's a subinterval. Here's a subinterval. Here's a subinterval. And here's a subinterval. And here's a subinterval. If you graph this, you can see that each one of these little brackets here represents, like we looked at in the top one, represents the interval width of a box, of one of the rectangles. So if we look at here, the right side is at 4, 6 units high. The interval width is 4, so for this first interval, delta x is 4, and the height of that xi is equal to 6 units high. So all we really need to do is multiply each one of these terms by 4, and then add them up. and that's what we can do. Okay, so if we're going to multiply each of these by 4 and add them up, I can really do it like this: 4 times 6 plus 12 plus 18 on up to 22. And if I add all those up, get my calculator out. Here, let me compute this real quick. So I did it on the calculator. I got 4 times 108. Okay, you got to remember to multiply it by the interval width, by 4, because you notice there's the distractor right there. So that equals, 648 feet. And so the answer to this one, my calculator messed that one up. Yeah, right. Blame it on the calculator, Jaffe. Good, good. Way to go. 432. And so the answer to this is C. I don't know how I got 648 the last time. Oh well. Okay. Problem 3. Problem 3 is basically taking a limit of a Riemann sum and turning it into an integral. Okay, and I showed you how to do that a couple days ago. This equals, the function equals 4x cubed minus 4x squared plus 1. There's the function. Okay, the integral then starts at 4, the left-hand endpoint, and goes to 8, the right-hand endpoint, dx. Cool, we just got to find what matches that. 4x cubed plus 4x squared plus 1. So it's going to be this one right here. So number 3 is D. Okay, number 4, evaluate numerically using your calculator. Okay, let me pull the calculator up real quick. So here's my calculator, and we'll just do math, fn int. Okay, the function is 5 divided by, and let's put the 2x squared in parentheses so we're sure that it gets computed in the proper order with respect to x from 2 to 4. And we get an answer of 0.625, and so this answer is equal to A. Yay! Okay, last question. The average value of the function, I did not tell you this during class, so that's why I gave it to you during the test. The average value of f is equal to 1 over b minus a integral from a to b of the function you're finding the average value of. So all we have to do is plug this in. 1 over 6 minus 3 integral from 3 to 6 of negative x squared plus 2x plus 13 dx. So let me go ahead and use the calculator and I'll figure out that integral real quick. So math fn int negative x squared plus 2x plus 13, okay, with respect to x from 3 to 6. So the integral is equal to 3. Well, that's convenient. And then 1/3 times 3 is equal to 1. And so the answer to 5 is B. And there's the multiple choice questions on the Unit A test.